guys, it's me Chiku from Chiku Study Corner, and today I'll be dealing with the part 6 of solutions. Solution is the chapter 2 of our textbook, that is Chemistry Class 12 CBSE. If you haven't watched the previous parts of this chapter, make sure you watch it and then continue watching. So, in the previous session, we discussed about colligative properties. So, how many colligative properties do we have to learn? We have to learn 4 colligative properties, out of which we learned 2 in the previous session, and we'll be dealing about the next 2 in this session. So, these colligative properties, which were the 2 that we learned? First one was relative lowering of vapor pressure. And the second one that we learned was elevation in boiling point. Now we have to learn about depression in freezing point and osmotic pressure. So, we discussed about these 2 now. Now we will see about depression in freezing point. That is our first thing that you have to learn. When do you say something is about to freeze? That is when. And what is a freezing point? The temperature at which the vapor pressure of both solid and liquid states of a substance have the substance are equal. Okay. So what is that? When the temperature, that is the temperature at which the vapor pressure of both solid and liquid state of a substance is equal. That temperature is called as freezing point. Okay. So what can you say? This is a dynamic equilibrium between both solid and liquid states. Okay. So that is what is freezing points. Let's see a graph and then we'll understand what I'll explain the graph to you. So let's see a graph and you will get a more clearer idea. So let's see. As usual, in the x-axis we have temperature and the y-axis we have vapor pressure. Okay, so the first graph is of our solvent. What solvent? Our liquid solvent. Okay, then it is of the solution. And before completely drawing the solution, let me show you this point. This line shows what? The frozen solvent. Okay. So, what did we say? We said when the the vapor pressure of this solution in both in liquid and solid states should be coming to equal value, then only you can say that started freezing. So the solution would have to produce a temperature more than that of solvent to start its freezing. So over here the pure solution, this solvent would start to freeze, and over here, because here it is a non-volatile solute that is being added. Okay, is being added to the solvent. Okay, so this is the graph. From here, let's mark the temperatures. So this is what? TF between these two is delta TF. So now let's derive the equation. So let's see what's the equation. So we know what? We have to find the difference. We have to find the relation between delta TF. So delta TF is equal to, which has a higher temperature or which has a higher freezing point, that is T0F minus TF. Okay. So this delta TF is proportional to molarity. Okay. So what happens? In the previous case when we learned, we put in a value KH. Yeah. Now we have that was for another quantity. Every quantity doesn't have the same constants. So over here, how do you remove it? TF is equal to KFM. KF is called as cryoscopic constant. The other one was ebullioscopic constant for the previous one. That was the elevation in boiling point. Okay. Now we know what is molarity. Let's figure out the equation. So delta TF is equal to KF into what? Molarity. How do you write the molarity? That is what? WB divided by MB into 1000 divided by WA. So this is our equation. So over here, if the molarity is equal to 1, what would happen? Delta TF would be equal to KF into 1. That is delta TF is equal to KF. Okay. So now we finished with this property also. The next colligative property that we have to learn is osmotic pressure. So let us see what is osmotic pressure. So, what is osmotic pressure? Before we learning what is osmotic pressure, let's just record what is osmosis. The term osmosis is learned by us in our previous lower classes. So let's see what is osmosis. Osmosis is the process by which the solvent molecules move from a lower concentration to a higher concentration where there is a semi-permeable membrane between them. So let's just draw a diagram to know what is osmosis. So this is our container. Over here we have a semi-permeable membrane, and here we have water. Okay. Here we have salt solution. There is salt in water. So what would happen? Where is there a lower concentration? From lower concentration, it will move to higher concentration. So from water, the water would move to the salt solution. Okay? So that is osmosis. So now what is osmotic pressure? Osmotic pressure is a process, or it is a pressure at which what happens? The osmosis between two substances are being stopped. Let's see. Let's take a U-shaped tube. Okay? In that, we have a semi-permeable membrane over here, and here are our solutions. This is water, and over here this is salt solution. So, what would happen? The water would move from here to here. Am I right? So, what would happen? Can you see these levels are equal? See, there's a balance. Now let's take another situation. Okay, here is a U-tube, and here is our water, here is our salt, here is the semi-permeable membrane. So why is this here? This is a a diagram to show the osmotic pressure. Over here, this is the solution. Am I right? Here we took salt solution and over here we have water. When you apply pressure over the solution, what happens? There would be that is not at any pressure, a particular pressure. The osmosis between these two would stop. That pressure is known as what? Osmotic pressure. So now let's see the equation for osmotic pressure. So let's see. Osmotic pressure is represented by a letter that is pi. Okay. So pi is proportional to molarity, not molality, molarity. Okay. So this molarity is represented as C for this equation. So the relation between pi and C is pi is equal to CRT. And what is molarity? That is the number of moles of solute divided by the total volume in liters. So it is what? C is equal to N2V. Okay. So let's substitute that over here. N2V divided into RT. Okay. Now we know how do you calculate the number of moles. I'm just rubbing this. How do you calculate the number of moles? Number of moles is equal to given mass divided by molar mass. Okay. You represent given mass as W and molar mass as M. So N2 is equal to pi is equal to W2 divided by M2 because we took it as N2 into V into RT. So this is our equation for osmotic pressure. I hope you might have understood all these colligative properties. So which all were the four colligative properties? The first one was relative lowering of vapor pressure. The second one was that is elevation in boiling point, and the third one was depression in freezing point, and the last one is osmotic pressure. To talk about osmotic pressure, I forgot to mention osmotic pressure is the only measurable property of a colloid we learned when we dealt with the chapter called surface chemistry. I told you osmotic pressure is the only colligative property that can be measured, at least can be measured in a colloidal solution. And in the previous colligative property, that is what? The freezing point, I told you Kf, that is a constant. It is called as what? It's called in three different names. What is that? Cryoscopic constant, freezing point depression constant, molar depression constant. These are the three names that's called for Kf. Okay. Kf is cryoscopic constant, freezing point depression constant, molar depression constant. So friends, that is all for the theory. Now let's discuss some questions. So let's see the four questions. I'll give you each example for each of the colligative properties. First, we'll discuss about an example of relative lowering of vapor pressure. So the question is, the vapor pressure of pure benzene at a certain temperature is 0.850 bar. A non-volatile, non-electrolyte solid weighing 0.50 gram is added to 39 grams of benzene. Vapor pressure of solution is 0.845 bar. What is the molar mass of the solid? So first we'll write down what all are given in the question. P0A is equal to 0.850 bar. PA is equal to 0.845 bar. WA is equal to 39 grams. MA is equal to 78 grams. WB is equal to 0.5 grams. So our equation is P0A minus PA divided by P0A is equal to chi B. Yeah? That is equal to what? 0.850 minus 0.845 divided by 0.85. That is equal to 5 divided by 850. So P0A minus PA divided by PA is equal to WB divided by MB into MA into WA. That is the value of mole fraction. So 5 divided by 850 is equal to 0.5 into 78 divided by MB into 39. So we'll take out MB and we'll do the values. So after doing the calculations, you will get the answer as 170 gram per mole. Okay? The next example is that of elevation of boiling point. So the question is, boiling point of water at 750 millimeter mercury is 96.63 degrees Celsius. How much sucrose is to be added to 500 grams of water such that it boils at 100 degrees Celsius? Given Kb is equal to 0.52 Kelvin per mole. So, in the question it's given Tb is equal to 100 degrees Celsius. Tb0 is equal to 99.63 degrees Celsius. Wa is equal to 500. So, what is delta Tb? That is equal to Tb minus Tb0, that is equal to 0.37 degrees Celsius. So, now we have to find out what is Wb. Mb value is equal to 342 because it's sucrose C12H22O11. So let's see. Delta Tb is equal to M into Kb. We know that. They have given the Kb value also. So 0.37 is equal to 0.52 into Wb divided by 342 into 1000 divided by 500. That is, Wb is equal to 121.5 gram. That is what you get after calculation. Now we'll discuss about an example of depression in freezing point. The question is, what is the freezing point of a solution prepared by adding 239 grams of copper 2 sulfate, pentahydrate to 4 liters of water? The freezing point depression of water is 1.86 degrees Celsius per mole. Solutions: 239.0 grams divided by 249.681 gram per mole is equal to 0.95722 moles. Delta T is equal to I is Van Hoff's factor. Okay, IKFM. So X is equal to that is delta T is equal to the Van Hoff's factor is 2. So 2 into 1.86 degrees Celsius into 0.95722 divided by 4 kgs. That is equal to X is equal to 0.89 degrees Celsius. The solution freezes at negative 0.89 degrees Celsius. The last example is of osmotic pressure. 200 centimeter cube of an aqueous solution of protein contains 1.26 grams of the protein. The osmotic pressure of such a solution is 300 Kelvin, is found to be 2.57 into 10 raised to 3 bar. Calculate the molar mass of the protein. So the answer would be pi is equal to 2.57 into 10 raised to minus 3 bar, that is given in the question. V is equal to 200 centimeter cube, that is equal to 0.2 liters. And the temperature is equal to 300 Kelvin. The R value is equal to 0.083. Now we'll calculate the molarity. M2 is equal to W2 RT divided by pi into V. We just arrange the equation so that we get the value of M2. That is equal to 1.26 into 0.83 into 300 divided by 2.57 into 10 raised to minus 3 into 0.2. So, after calculations, the answer would be 61.022 grams per mole.
So, we've come to the end of this chapter. I hope you might have understood the chapter well. If you've understood it and liked it, please give my video a huge thumbs up and also subscribe to my channel if you're new to it. And share my video with your other friends. So, see you all in my next video. Till then, bye-bye.